Right. We are going to talk about confidence intervals, and we're going to do so using an example with TinkerPlots. So here's our example. So a new cardiac drug is given to a patient after open heart surgery. The pharmaceutical company that makes the drug claims that 20% of people that take the drug will suffer from headaches. A doctor has been using this drug on many patients and seems to notice that more than 20% of his patients complain of the headaches. This is what we observe. He has the hospital statistician gather a random sample of 50 patients that have used the drug and finds that 40% complain of headaches while on the drug. So this is the data that we now have. Do we have evidence against the 20% claim? So the null hypothesis for this test is that the proportion of people or proportion of patients on the drug will have headaches is 20%. The alternative is that it's greater than 20%. So let's simulate this so we can estimate a p-value. So here I have TinkerPlots. I'm going to pull down a sampler and a spinner. We're going to call this headache versus not. And we always build the sampler for a hypothesis test based on the null hypothesis. So I have 20% that are going to have headaches, 80% that are not. Then I'm going to draw one person 50 times because, as you'll recall, we drew 50 patients and found that 40%. So we want to build our simulation based on the data that we have. We had 50 patients. So we're going to do samples of size 50. And we can start running this. And of course, it just kind of goes, and we can speed this up to make it go faster. So this is my side effect data. Now I can look at it. So I'm going to click there. Grab a plot, look at my plot. Okay, resize just a little bit here. And so we've got, let's see here, let's count them. We got 28% that had headaches. So I'm going to collect that statistic, and then I'm going to do this several more times. Now to save time in the video, I've already done this. So over here, I have the same simulation, 20% drawn 50 times. I've collected the statistic 220 some odd times. No, I've collected it 400 times. 401 actually. And this is what we have. So we found 40%. This simulation is built on 20%. Notice that the center of this distribution is at 20%. So let's look at estimating our p-value. I don't care about the left because the hypothesis test was right-tailed. And I want to go find my 40%. Well, my 40% is way the heck out here. And so my p-value is, it says 0. Remember, TinkerPlots will round for you. So my p-value here is less than 1%. That's about as good as we can say from TinkerPlots. I'll put an exclamation mark there because that is really small, and that means we reject the null hypothesis. What that really means is we seem to have evidence against this 20%. We have evidence in favor that it's more than 20%. Now something interesting can be done. Now that we've rejected the null hypothesis, our p-value was less than 1%. Our decision was to reject. Well, we know that it's not 20%, but what is it? So the only way to do this is to estimate, make a point estimate based on our data, because our data point is now the only piece of information we have. So let's grab this again. I'm going to get myself a brand new TinkerPlots simulation. Here we are. And I'm going to build a new simulation, but now based on 40. So here's my new simulation. This is headache versus not. I'm going to draw one person 50 times, but now I'm going to make sure that, oops, I want percents, there we go. 40%. So what we did was we gathered data, we rejected the hypothesis that it was 20, We think it could be 40, but we're pretty sure it's not 40. So we're going to run this one, and we're going to run it quickly. There we go. So this is, again, my side effect data. Let's plot it and see what it looks like. So here it is. I'm going to separate it out, count it, and get some percents. Okay, so collect that statistic, and there we go. Now I could do this many, many, many times, which I've done in one of these, this one. Okay, so I've already done this. I've collected this statistic 301 times, so many, many times. I could do it another 100 if I wanted to. I've got 40% on sample sizes of 50, and here's my sampling distribution. Notice it's centered around 40, and if I put the dividers in there, now this time I'm interested in a far different question. I'm interested in estimating what the true proportion is. We know it's not 20, 20 somewhere over here. So the standard is to get what's called a 95% confidence interval. So I'm going to drag my sliders out here until I gather a symmetric range that picks up about 95%. Okay, there we go. I got 2% and 3%, so I got 95 here. So what this tells me is that I'm pretty sure, I am 95% confident that the true proportion of people that have headaches on this drug is going to be between 26% and about 53%. So coming back to here, let's write that down. We are 95% confident that the true proportion of people that get headaches on this drug is between 26% and 53%. And again, I got that by taking a distribution at my data point with the same sample size and then finding 95% around the center. So 95% in the gray box here, so it's 26 to about 53. I could maybe go out a little bit higher and I don't gather any more data. All right, I hope this helps you understand what we're doing with the confidence interval. There are many different situations where you would have a confidence, but basically it's when you only have your data point and you want to make an estimate. All right, have fun, be safe out there in stats land.